And now for the really cool part, standard deviation. Now, this is a really cool applet that's on GeoGebra that's going to let me explore a more powerful way to measure spread than IQR. So first of all, these are some data points that I have here, and we've taken the average or the mean, and that's 1.4. And the cool thing is, if I move the data point, you can see how this is dragging the mean lower as I pull it further away from the group, right? So basically, if I wanted to look at the spread of the data, one thing I could do is look at all these numbers here. Now, this is E is 4.6 above the mean, D is 2.6, C is 1.6 above the mean. A and B are both below the means, and you can see this should show a negative, but the software is a little picky, and it's showing the negative here. So these are below the means. So these are called the deviations, which is the distance from the point to the mean. I can't really use the total deviation because that's 0. And 0 is not going to tell me a lot about the spread. If I move the point, it's still 0. Even if I bring these over this way, it never changes from 0. So I don't want to use that point. I don't want to use just the deviation. So how can I make this not add up to 0? I could square them. And if I square them, they're all going to be positive. And when I add up the total positive, which is right here, I'm going to get a nice big number that would be helpful for spread. The only problem with this number is if I have more data points, the number is going to be bigger, and I don't want to penalize myself for the number of data points. So what I'm going to do is divide that number, the sum of the squared deviations, so this is the deviation, these are the squared deviations, divide that number by, in this case I have 5 data points, we're going to divide it by 4. It's always dividing it by n minus 1. So this is called the variance, when I sum up the squared deviations, add them up, and divide by n minus 1, where n is the number of data points. Now, I do want to get back to the units of measure because 20.7 doesn't feel right for this. So I want to take the square root of that to get back to something more closer to this, that's closer to the spread. And that gives me 3.87. And this, the abbreviation for it is SD, or standard deviation. So the way that we do it, again, and your calculator will do this automatically, is we just take the data point minus the mean, or the mean minus, the data point minus the mean, square them, add them up, divide by n minus 1, and then take the square root to get the standard deviation. So you'll often see variance and standard deviation when you're looking at data. So if you want to do standard deviation, this is the formula you see on your math chart right here. The good news is your calculator is going to do most of the work for you. And normally you won't have to substitute into this formula because that sigma there, that sum, means you're adding up a lot of terms, and they're not going to make you do that. Other formulas, it's very important that you substitute into them. So anyways, how do we do that? Well, first of all, what we're going to do is we're going to press stat on our calculator, and we want to make sure that we have our data in a list. Then we arrow over to calc, and you see that first selection, 1 var stats. Go ahead and press enter, but then you need to put in the list name, which we're going to do L1 in this case, and press enter, and it's going to give you a display like this. So you have the one that is the standard deviation is S of X right there. So I've highlighted it here. Now your calculator doesn't give you variance, so all you have to do is square the S of X, and that will give you the variance. And here's the formula for variance. So some more about variation. Remember, if the data is tightly clustered around the center, the IQR and the standard deviation will be small, which makes sense because the spread should be small. When they are widely scattered, the IQR and standard deviation will be large. So what should you include when you're describing your data? Always, 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 always make a picture. I know when I went through that workshop, he said, first thing you start with is a picture of your data, because it's very easy to let the numbers lull you into false sense of security. Thinking, oh, I know what's going on, but those outliers are going to get you. Always describe the shape of the distribution along with the center and the spread. If the shape is skewed, go ahead and report the median and the IQR. If it's symmetric, report the mean, the standard deviation, and it doesn't really hurt to report the median and the IQR as well. Always report clear outliers. You should examine your data with outliers present and outliers removed. You may remove an outlier if you have a good explanation. If you can't, then you should use the median and the IQR, which are not usually affected. I know when we sold instrumentation, we would occasionally have an outlier, and it could be someone put the wrong sample in the bottle. We had to really go and make sure that we had a good reason for removing that data point before we went ahead with that. So be careful of multiple peaks. I know we haven't looked at those, so things that are not unimodal. And what that's going to mean when we do encounter them is that there are multiple groups within our data. Be careful about comparing groups with very different spreads. For example, this is measuring the level of cotinine or cotinine. In basically, you've got smokers, people who are not exposed to smoke, and then people who are exposed to smoke. So if you're looking at it, you're really just seeing the smoker data. So what you can do is re-express this, redo it in a different scale. Here we used a logarithmic scale so that you can actually see the outliers for all of the groups that do have outliers. And you can better compare the medians for the people who aren't exposed and those who are. So if we had only looked at the left data, we might think there are no effects from secondhand smoke. But if you look at the next graph, then you can see